Let's talk about the consequences of having a lock on the code like we've described in this scenario. How does that affect Grace's workflow? Our first instinct would be to look at this and say, well, if Martin's locked the code, then that means that Grace would be able to maybe make changes locally, but she just won't be able to push them until Martin has released that lock. That fits with patterns of older source control tools which supported locks like this, but it doesn't really fit for our desire for strong consistency. Our desire for strong consistency means that if we ask Martin what the state of the code is and we ask Grace what the state of the code is, they need to be able to give us the same answer. Now, if Grace is modifying the code and Martin is modifying the code, their code is going to look different and they will tell us something totally different. So that means that not only is Grace not able to push her changes until the lock is released, she actually can't make her changes because the moment she starts changing her code, it's going to diverge from whatever Martin had. So she's not even allowed to change the code and then hopefully push it later with some sort of merge operation. That's not allowed in this scenario. But it goes a little bit further than that, because even if Grace doesn't change her code, she leaves it completely as is, we still have the problem that Martin may be changing it on his side, which means that Martin's version of the code is diverging from Grace's version of the code. Now, because of that, if we are to ask Grace what the current state of the code is, she doesn't know. Only Martin knows that at that point. That means that it also means that Grace can't even read the code. If we go to ask Grace what the current state of the code is, her only answer can be, I'm not sure, I'll have to get back to you once Martin has committed. If she looks at the code, she is looking at something that is stale. And again, strong consistency means we don't want to have stale data. So Grace is not allowed to read the code. It goes further than that, though, because this code includes things like a method signature. Now, if Grace wants to go edit other code that relies on that method signature, she's operating on out-of-date information. Martin may have changed the method signature. So really what we're saying is Grace can't write the code, she can't read the code, and she can't write any code that uses this code. This severely restricts what Grace can or can't do. And we have to then start asking questions about, well, okay, she can't edit any code that might use this code, but can she edit the code that uses this code? How far does that really go? The point here is that this is a very inefficient workflow for Grace. Really, what we're saying is that in this scenario, Martin can work with the code or Grace can work with the code, not both. We don't need one of these people. We can just fire them. So we could just say, you know what? Grace can't actually do anything, so let's just, lay her off and give all the work to Martin. That's not going to be very good for Grace. And honestly, it's not very good for the business because, again, it's very inefficient. So how do source control tools actually achieve consistency? Well, the first thing to recognize is that, as far as I know, every source control tool out there operates on an eventually consistent basis. You make changes locally, and then you push those changes. When you push those changes up to the repository, you have to usually go through some sort of merge process. Now, there are some older source control tools that would create locks. And what those locks would do is they would potentially, depending on the source control tool, they might allow you to read the code, but not necessarily edit it. Or they might allow you to edit the code, but not push your changes until the lock is released. But in either case, you're still dealing with an eventually consistent system because, again, the code that you are looking at, whether it's to read or edit, is now potentially out of date. What they do is they rely on a later merge operation in order to bring things back into alignment. That's how modern source control tools achieve consistency, and it's all an eventually consistent system.